In this video, we're going to model exponential decay. It says a small object with an initial temperature of 135 degrees Fahrenheit is dropped into a tub with a temperature of 60 degrees Fahrenheit. The function f of t equals c e to the negative kt plus 60 represents the situation where t is in time in minutes, c is a constant, and k is a constant. After 6 minutes, the object has a temperature of 85 degrees. What is the approximate value of k? So they want us to find k, which is a constant. They want us to find, well, we're going to have to find c, which is a constant, because if we don't have c, it's going to be tough to solve for k, because we only have one equation and we got two different variables. They give us some information. They tell us two different pieces. They tell us 0 time was 135 degrees. Say degrees Fahrenheit. And then also they tell us that 6 minutes was 85 degrees Fahrenheit. We're going to use this, basically this is the y-intercept because x is 0. We're going to use this to find what that c value is, because I can plug that into the equation. So f of t is going to be our temperature. So we're going to say 135 equals c e to the negative k times 0 plus 60. If I take negative k times 0, it's 0, so I get 135 equals c e to the 0 plus 60. Subtract 60 on each side, and I get 75 equals c e to the 0. We know e to the 0 is just 1, so 75 is what c is. That's the nice part about using the y-intercept or having time 0 is we can cancel out that exponent and then solve for that leading coefficient. Let's plug that into the equation. So we really have f of t equals 75 e to the negative kt plus 60. They say after 6 minutes, the object has a temperature of 85 degrees. What is the approximate value of k? So they want us to use this coordinate 6 and 85 to solve for k. We plug in 85. We're plugging 6 in for t, so we end up with negative 6k. We're going to divide by 75 on each side. Nope, not divide by 75. I got this plus 60 out here. Let's subtract 60 first. And that's 25 equals 75 e to the negative 6k. Then we'll divide by 75 to isolate the exponential. And that'll be 1/3 equals e to the negative 6k. Let's take the natural log of each side. Natural log 1/3 equals natural log of e to the negative 6k. This natural log e is log base e of e. It's a log law. This is 1. I can also use the other log law, the power rule, to bring negative 6k to the front. So we have natural log of 1/3 equals negative 6k. We're going to divide by negative 6 on each side. And so k is going to equal, plug that in the calculator, natural log 1 divided by 3 divided by negative 6. We get 0.183. They told us to round to 3 decimal places. So that's our constant value k.